Hi everyone, today's goal is to identify similar figures and find unknown lengths. We're also going to be using proportions to solve problems. Similar figures. They're the same shape but not always the same size. And this little squiggly line is the symbol for it. The corresponding angles have to be congruent, which means the same. And the lengths of the corresponding sides have to be in proportion. Congruent angles, for those of you that don't remember, are angles that are equal in measure. To identify similar polygons, you need to make sure those two criteria are met. So the first thing you're going to do is check to see if the corresponding angles are the same or congruent. And then you're going to check to see if the corresponding sides are in proportion. Both of those criteria have to be met in order for something to be similar. Are these similar? Here's two rectangles. The angles are all the same, but we need to check to see if the sides are in proportion. So we would compare 4 to 10. Is that equal to 3/9? Again, short side compared to long side, short side compared to long side. You have to set your proportion up the same way on both sides of the equal sign. When you do this work, you will find out that they are not in proportion. The fractions that are represented here, or ratios I should say, are not equivalent. If you cross multiply, 10 times 3 is 30, and 4 times 9 is 36. They are not equal, so they are not in proportion and not similar. Here's another example. Two rectangles, 18 by 27 and 36 by 54. Again, when you set your proportions up or your ratios up, you need to make sure that you're using corresponding sides. So we have 18 to 27, short side to long side, to 36 to 54, short side to long side. Just because the 18 and the 54 are on top here doesn't mean that they correspond to that place in the ratios. Okay, you have to match the sides up. In this case, when you do the math, cross multiply, you will find out that they are in fact equivalent and in proportion, therefore similar. If you are told to find a missing length in a figure that is similar, you can use a proportion to solve it. You need to make sure you match the sides up correctly as well as the angles. And if you're given a statement like this, a similarity statement, keep in mind that A is going to correspond to X. B is going to correspond to Y. It goes in the same order. Line segment DE is going to correspond to line segment PL. Line segment LX would correspond to EA. Okay, here's an example. You want to find X. So again, even though the triangles are a little mismatched, meaning this one's rotated a little bit, you still have to match the corresponding sides up. So we have the hypotenuse 16, or I'm sorry, the longer side here, 16, is compared to X, and then the corresponding side, 24, is compared to 18. Cross multiply and solve, and you would get X is equal to 12. Here's another one, and you need to be a little bit more careful on this one. The right angle here is B. The right angle over here is F. So when you're setting this up, you actually need to take this triangle, well, let's see if I can find it, and spin it. That way all your sides correspond. So now if we were looking for Y, we have 3 is to 4, as Y is to 256. Okay, again, you have to be very careful that your sides correspond. and you would cross multiply and solve. Here's another very common one. You're looking for the length of D, and you need to be a little bit careful with this. So we have a small triangle here inside the larger one. The ratio for the small triangle would be 12 over 14, and the ratio for the larger triangle would not be 9. You would actually have to add 9 and 12 together. So it would be 21, which is this whole length over D. Okay, so be careful with that. That's very common. A lot of times people will just put 9 over D, but it's actually the whole length. You need to add them together. Okay, you would cross multiply and solve and get D was equal to 24.5. A scale model is similar to the actual objects it represents. A scale is the ratio of the length of the model to the corresponding length of the actual object. Here's a map of the United States. If your scale states 3 inches equals 200 miles, and you want to figure out how many miles 10 inches is on the map, how would you do it? Well, you're going to set up a proportion. Whenever you have a map, you put the map length over the actual length in real life. So in this case, it would be 3 inches over 200 miles, and it's going to be equal to 10 inches, because that's the map again, over how long it is in real life. Okay, and again, you're going to do your cross multiplication and solve for x, and we get approximately 666, and 6 repeating. The student who is 5 1/4 feet tall is standing next to a tree. The shadow of the student is 20 feet and the shadow of the tree is 80 feet. What is the height of the tree? Well, here's something, and don't laugh, you may want to draw a picture for. Here's the student at 5 1/4 feet and their shadow at 20. Here's my very poor picture of a tree and the shadow that's 80 feet long. And if you look, you can actually see two triangles. They would be right triangles, so they would be similar. X would be your length of the tree. So you're going to set your proportion up. And again, there's a couple of ways you can set it up, but you have to make sure you set the right side up the exact same as you do the left. I like to use the shorter side over the longer side. So I'd have 5 1/4 over 20 would be equal to X over the shadow length of 80. You can also compare the two shadows to each other. First, 20 over 80, short shadow to long one, over the short length to the longer length, 5 1/4 over X. Okay, again, you would cross multiply and solve for this. 1 inch represents 12 miles on a map. If the distance between the two buildings is 4 inches on the map, what is the actual distance? So again, remember with map problems, we're doing map over actual. So on the map, 1 inch is equal to 12 miles. And then we want to know how much 4 inches is in real life, so that would be over X miles. Cross multiply and your answer would be 48. A model of a new campus building is 5 inches tall. If 1 inch represents 8 1/2 feet, how tall will the building be? Again, map over actual, map over what we're looking for, the actual height in real life. Cross multiply and solve, and you would get 42 1/2 feet. One more example. If there are 1,200 calories in 8 ounces of hot fudge, how many calories are in 3 ounces? Again, you can set up a proportion to solve this. 8 ounces over 1,200 calories is equal to 3 ounces over X. Cross multiply, divide by 8, and you would get X is equal to 450 calories. You have to think, is it worth it?